Greetings! In this video, we're going to take a look at how the ISA and HASA relationships can influence the design of your classes. Now, just as a quick overview here, on the ISA and HASA relationships. The ISA relationship is pretty much the straight-up inheritance relationship. Class C inherits from Class B inherits from Class A. In that case, you would say that B is an instance of A, and that C is both an instance of A and B. The HASA relationship is where you've got other types of classes as member variables of a class. For example, I might have a car class that also has a reference to an engine class, and maybe 4 references to tire classes. That would be an example of a HASA relationship. And understanding how these two relationships go together and work together influences how you design your objects. Now, let's take a look at just the pure ISA relationship, because this is usually what gets most people. You cannot think of object design in terms of real-world hierarchies. It works, sort of, but it rapidly starts to break down. Let's look at cars for a moment. You might think it's perfectly logical to, say, have a base class of automobile, and then from there, say, have a class car that inherits from automobile, and a class truck that inherits from automobile. Maybe further from truck, you can have an F-150. And then maybe even further from there, maybe an F-150A representing a different variant of a Ford F-150. And it works okay. I'm not saying you can't do it that way, but you rapidly start getting into some really weird situations. For example, while they've pretty much gone out of style, there used to be these really weird car/truck things. They were mostly cars, but instead of a standard trunk, they had a small truck bed. So how do you fit something like that in your inheritance scheme? Is this a car or is this a truck? Perhaps a little bit better example would be, let's say we've got spaceships and we've got machine guns and we've got missiles. Pretty simple. We'd have a weapon class, and machine guns would inherit from weapon, and missiles would inherit from weapon. And then let's say we have tracking missiles. Okay, fine. Tracking missiles inherits from missiles. Not a problem. But now, what if we want to have smart bullets? This is sci-fi. We can have smart bullets. Nothing wrong with that. But where do we place this in our hierarchy structure? Do we have a smart bullet machine gun inherit from machine gun? Well, we can do that, but now we've got duplicate code. We're going to have to duplicate the tracking code from the missiles over to the machine guns. Or we could perhaps, say, try to inherit off of the tracking missiles, but now we're going to have to write in special exception code to get the quote-unquote missiles to behave properly like machine guns. And so you can see you start getting into some quagmire. So enough talk. Let's look at some practical, if but stripped down versions of this project here that we got. Now, before I start looking into the inheritance levels, I do want to take a quick moment to talk about this GameObject class here, which is very simple, and why pretty much everything inherits from GameObject. This is a very common programming technique. Having everything inherit from GameObject allows you to do a couple of optimizations. It allows you to stuff everything into a singular list, so that way you can update things easily. For example, if we come over here to program.cs, we can see that I've got a scout ship. A is a scout ship. B is a scout ship variant A. These are both separate classes, but because scout ship inherits from GameObject and scout ship variant A inherits from scout ship, both of them are game objects, and so I can add both of these to this list of game objects. That makes it very convenient. So whether it's a ship, a missile, an asteroid, a base, it doesn't matter. If it's a game object that's in the current scene, I can add it to this list and say, okay, you know what? All game objects, go update. And just iterate over that list and update all of my game objects. It's really nice. So that's why we got that game object there, and everybody inherits off of that. Now let's take a look at these scout ships, because this uses the inheritance chain. I've got a scout ship, and it's got a light cannon. Go ahead and bring that up. The light cannon doesn't exist all on its own in the game world, so it does not inherit from game object. And you see just some basic, it does damage, it reports what it does. But now let's say maybe I've got a variant of the scout ship that has a different kind of cannon. It has light cannon variant A. And if I look at this, using stealth variant location not reported. So this is a stealth cannon. The enemy ships can't figure out where the shot's coming from. So I have to create a separate inheritance off a scout ship. I basically hide the parent class cannon, which forces me to do an override on the fire weapons. And if we run this, we can see it works correctly. Now, damage done 10, reporting location of ship to target. Damage done 7, using stealth variant, location not reported. And we can see here, A.fireweapons, B.fireweapons. Now, it does what we ask it to do, and it's not overly complicated. It's actually a lot less complicated than the component version, but it's brittle. For every new type of scout ship, I've got to create a brand new class. For every new type of cannon, I've got to create a brand new class. If I want to have two different weapons that have a little bit of mixed functionality, they both share some common ground, but they've got some differences, I need two separate classes, I've got duplicate code. It starts becoming very difficult to maintain if you've got an extremely complex project. Again, I am not saying that this is bad. Inheritance chains can be very useful. You just have to be aware of when you want to use them. And attempting to use inheritance chains to model real-world hierarchies, it's not a good idea. What a lot of games do, and this is also how Unity operates, is they operate more on a component system. So let's get some of this stuff closed out here. And the component system is where you've got components, and basically you rely very heavily on the HASA relationship. You're not really relying so much on inheritance, although it's still there, but rather you are adding in additional instances of other classes to get the functionality that you want. You can see here, this one's a little bit more complicated. Now this time, I've only got one spaceship class, but I get two very different spaceships from this. Program.cs. Now, so I've got a scout and I've got a cruiser. Both of these ships have very different weapons, and if this was a more fleshed out thing, I could have them very different from each other. But I can do this with a single ship instance, a single ship class. And how we do this is components. So in this very stripped down version, I have a list again of weapon systems. A quick word on the list, because you see me use this a lot. A list is a really great generalized data structure. It has constant insert time. You always add things on to the end of a list. And it has linear growth to search times. You always start from the beginning of the list and navigate to the end when looking for things. So it has a linear growth, which is not the greatest, but it's also not bad either. Unless you've got some extreme performance requirements, or you've got, say, perhaps tens of thousands of items in your list. Thank you, Avast. Now, you're not going to have to worry about the performance issues. So the list data structure is a excellent generic data structure, sort of your go-to data structure. It's like, okay, I need a list, I need store stuff, and let's throw it into a list until we know otherwise. So I've got a list of weapon systems. And if I come over here and I look at what a weapon system is a collection of parts. Now notice I have a list of interfaces. Now that might seem a little bit confusing at first because you can't actually create an instance of an interface. Remember, an interface is simply a contract, a list of functions that a class promises to implement. So how can I have a list of interfaces? Well, the interface sort of links in to the ISA side of things. If something implements an interface, you can say that it is that interface. And so since in this particular case, what I need here is the part that has this interface implemented. All I have to do is call the implemented methods from this interface, and it's going to call the appropriate code on that class. So if I look here, I have got rapid fire bullets, weapon part system, rapid fire bullets. It implements, I should say, the I weapon system part. So it is a weapon system part, and it implements the different actions. If I look at target tracking, same thing. It implements things just differently. Oops, there's supposed to be a 0 there, just for clarity's sake. And again, implements the interface, implements all the necessary methods. So all of these things here, this class here implements this part system, which means I can add it into this list. And so I've got add part, which you pass in a part and it adds it to the parts list. And then when you fire the weapon, it goes through all of its parts and calls the action on fire. When you reload, it goes through all of its parts and calls the action on reload. When it's time to update, again, it goes through all of its parts and calls update. This way, I can build a wide variety of weapon systems with just, these classes, with these, three things here. I can build a kind of a wide variety of things. I mean, I've got to have the rapid fire bullets. It's kind of the only sort of core damage system I got. But I can have just regular rapid fire bullets. I could have armor piercing bullets. I could have target tracking bullets. Or like in the Mega Gun, I can have it all. Rapid fire bullets, armor piercing, and target tracking. And so I just declare new instances of these and toss them in to the add part method. So I create a new instance of rapid fire bullet, toss it into dumb gun. And then I do the same thing for the Mega Gun, creating a new instance of rapid fire, armor piercing, and target tracking. And then when I call the appropriate methods, fire, reload, update, fire, reload, update. You can see with a little bit of help with color coding here. And everything works out okay. So I'm firing the dumb gun, damage done. If I skip down here to firing the Mega Gun, I see my damage done, do extra damage to armor, make adjustments for tracking, indicating that those three components are active. But when I reload the dumb gun, reload in 0.1 seconds. When I reload the Mega Gun, reload in 0.1, slow down by 0.02, slow down by 0.05. So the component system is working. So you can see here very easily, now if I expanded this out and say I had components for engines and components for armor plating, now still one spaceship class, and I could have everything from small light fighters to massive gargantuan carriers. It's just a carrier would have, the components for, launching fighters and storing fighters and things like that. The drawback to the component system is that it's a lot more complicated and takes a lot more thought to set up correctly. The straight-up inheritance system, still requires some thought, but it's nowhere near as difficult to set up as a good component system. So there are some trade-offs there. Now, with the component system, you're going to be doing a lot of your work up front, but after you get that component system done, it's really easy to customize. Again, this is how Unity does things. With Unity, remember you've got your standard game object that always has that transform component, and then to give that game object different behaviors, you add on different components to that game object. And that concludes this video. This sample code will be up on the Google Source Control, the Google projects. Keep in mind, we're sort of in a transition period as of the recording of this video of transitioning between Visual Studio 2010 and Visual Studio 2012. This is a 2012 project. It might not import correctly into a 2010 version of Visual Studio. If that is the case, all you need to do is just simply create a new project and add these in. I will attempt to get a Visual Studio 2010 version of this project up and running, but there can be no real guarantees on when that will happen. And with that, until the next video.